Mirror test for snakes. Are these reptiles aware of themselves? The mirror test is a common method of testing animals' cognitive abilities and self-awareness. Recent research on snakes using an olfactory version of the mirror test has shown that these reptiles can distinguish their own scent from that of others. The mirror test was developed as a method of examining self-awareness. It was first used in the 1970s on a group of chimpanzees who had never seen a mirror before. The monkeys initially took the reflection in the mirror as a threat, as other, unknown individuals. But after some time they realized that they saw their own reflections in the mirror. Such a change in behavior, researchers argue, reflects a certain amount of self-awareness, a mental model of one's own body as opposed to that of friends, enemies or other parts of the environment. The test involves painting a colored dot on the animal's body that it cannot see without a mirror, for example on the forehead. The animal should react to the new feature of its body visible in the mirror by touching it and trying to remove it. If he does this, it means he recognizes his reflection in the mirror. In other words, he is aware that he is looking at himself and not another individual. This test is considered by behavioral scientists as a benchmark for higher-level cognitive abilities. Many species have passed the test so far, including several species of monkeys, elephants, pigs, dolphins, killer whales and birds from the corvid family, but also pigeons and some fish. On average, children can pass the mirror test after 18 months. But there are species for which the mirror test simply does not work, because they perceive the world mainly through smells, not sight. These include snakes. Snakes and most reptiles interact with the world primarily through smell, says Noam Miller of Wilfrid Laurier University in Canada. Snakes rely primarily on scent. Although some species, especially arboreal ones, have very good eyesight. The constant waving of their forked tongue, characteristic of snakes, is nothing more than taking samples from the environment and analyzing their chemical composition. Thanks to this, they can recognize potential victims or predators in the area from which they should hide. Miller and his colleagues developed an alternative, olfactory version of the mirror test. The researchers collected the scents of 36 garter monkeys, Thamnophis sirtalis, and 18 royal pythons, Python regius, by rubbing their skin with cotton buds. They then gave each snake 5 scents. Their own with a little olive oil, olive only, one other snake of the same species, and another snake of the same species with a little olive oil. Garter monkeys made more long tongue movements in response to exposure to their own odor and their own oil-modified odor, compared to the other odors. Snakes only make long tongue movements when they are interested in something or investigating something, says Miller, adding that their behavior suggests that they can recognize each other's scent. In turn, royal pythons reacted in the same way to all odors. Researchers suggest that the difference between the two species' response to different odors may be because garter snakes are more social animals than royal pythons. They also suggest that such species have a greater predisposition to self-recognition, and this ability may evolve in response to species-specific ecological challenges. According to the scientists, their research is the first evidence that snakes can recognize their own smell, have a mental model of it, and can distinguish it from the smell of other animals. According to scientists, this research may also change popular opinion about snakes. There is an assumption that snakes and almost all reptiles are slow, instinctive and cognitively deprived animals, which is not true, Miller emphasized. However, not all researchers agree with the conclusions drawn from the study. Part of the scientific community criticizes the mirror test itself as a measure of animals' cognitive abilities, or more broadly, as an indicator of self-awareness. Many animals that we consider social and intelligent, such as dogs and cats, fail the mirror test. Failure on the test does not necessarily indicate a deficit in cognitive abilities. The results and description of the research were published in the journal, Proceedings of the Royal Society B. Biological Sciences. Scientists have found a way to obtain energy from the air. Researchers from the University of Massachusetts Amherst demonstrated to the world a device that can continuously obtain electricity from moisture in the air. Moreover, almost any material can be turned into similar equipment, as long as it is filled with nanopores smaller than 100 nanometers in diameter. However, currently this solution is not yet ready for practical use, but, according to its creators, it goes beyond some of the limitations of other methods of obtaining energy. Mankind's demand for electricity is growing every year. Where else can we get it? It turns out that some of its potential sources are difficult to see, but this energy is literally at your fingertips. This was proven by researchers from the University of Massachusetts Amherst. They have developed a device that can draw energy from air humidity. The description and results of the research were published in the journal, Advanced Materials. The condition for the operation of the device developed by American researchers is air. Or perhaps not the air itself, but its appropriate humidity. To illustrate this, just think about the cloud for a moment. As we know, it is a huge concentration of water droplets. And each of these droplets has some electrical charge. When conditions become favorable, these charges can cause lightning to form in the cloud. However, for now, obtaining electricity directly from lightning is beyond our capabilities. Therefore, we should try to use this energy before lightning strikes occur. And this is the idea of a group of scientists. So far, they have managed to create a small cloud in the laboratory that is able to produce energy in a controlled and predictable way. But how is something like this even possible? What is the mechanism of operation of such a power generator? Well, according to the creators of this method, it is relatively simple. All we need for this is a porous material in which the pores, or rather nanopores, would be only 100 nanometers in diameter. This seems like one of those easier said than done tasks, although it is not impossible. In any case, relating it to the dimensions we can imagine, it is approximately 1/1000th of the thickness of a human hair. Why 100 nanometers? This is due to a parameter known as the mean free path, which is the distance that a single molecule of a given substance, in this case water in air, travels before it collides with another single molecule of the same substance. When water molecules are suspended in air, their mean free path is approximately 100 nanometers. How it's working? A thin layer of nanoporous material can be made of, for example, cellulose or graphene oxide. Water particles in the air easily penetrate the nanopores. Then they gradually move from top to bottom, but along the way they move along the walls of the pores. This means that the upper part of the layer of porous material would be bombarded with much more charge-carrying water molecules than its lower part, creating a charge imbalance, just like in a cloud. Because we observe something similar in the context of the formation of lightning. This is how a generator was created that can operate as long as there is moisture in the air. The energy produced in this way could be used to power a small device or be stored in batteries. However, we should not expect that in a moment we will sit comfortably in the park on a day when the air humidity will be high and simply take out the panel, thanks to which we can, for example, charge our smartphone. Currently, the work is still at a very early stage. For example, using a layer of cellulose material, it was possible to generate a voltage of only 260 millivolts, while a mobile phone requires at least 5 volts. However, such layers can be accumulated, increasing their capabilities. The most important thing, however, is the fact that the observed effect exists and opens up many possibilities for us. Moisture is almost always present in the air, so such a generator could run 24/7, rain or shine, night or day, regardless of whether the wind is blowing. This solves one of the main problems of technologies obtaining energy from wind or solar, which only work under certain conditions.